This is a demonstration of volume by cross-sections. If you've already watched the 7-2 Day 1 notes, you will already have seen that there are 3 ways to find volume: volume by cross-section, volume by revolution, and volume by shells. We won't do shells until after the AP test because it's not tested on the AP test, so we'll wait till May to do that one. This video is demonstrating the volume by cross-sections. So we've got a circle on our coordinate plane. And if I draw vertical lines up and down, I have a whole bunch of vertical lines that go from the top of the circle to the bottom of the circle. I'm going to drop the y-axis so you can see the third dimension. So there's 4 squares. The closer to the end of the circle we are, the smaller the square is. The closer to the diameter, the bigger the square is. If I take 1 square, it gets bigger as I get close to the diameter. And then it gets smaller as it gets further away. Drops off pretty rapidly right there. There it goes. Okay. If I created each of these squares and built onto them to make a 3-dimensional object, it creates an object. It creates a solid figure. So that solid figure right there, you can see it as you go. Okay, so it's a little small. The other side kind of looks like an amphitheater. All right, let's try another one. Okay, so same circle, same vertical lines. I'm going to drop the y-axis so you can see the triangles being swept across. So same thing like the squares, except now we've got a triangle, and it's an equilateral triangle. So if I create the shape with a different cross section, the shape looks different. Right now it kind of looks like a tent to me. What does it look like to you? And let me show you the whole solid. There you go. Same thing with a right isosceles triangle. Again, same base, different shape makes a different it makes a different 3-dimensional object. It makes a different solid. That looks like the amphitheaters in the park where the band sits in front of, and then they have the back to focus all the sound going forward. Okay, so let's reset this one. Okay, this one is a triangle as a base. So if I drop the y-axis, that's still the same triangle. And I'm going to take a semicircle and make a solid. So if I create that solid as I go, kind of looks like the top half of an ice cream cone to me. If I put 2 of those together, I'd have an ice cream cone. Okay. And there's some AP problems. Let's look at one of these AP problems. We'll just pick one. Oh, I can't actually pick on any of these. They're just examples that we can go do and look at. Okay, well, that was a visual demonstration of volume by cross-section.